As promised, this is your midterm review. Well, the first in a series of videos for the midterm review for Algebra 2 Honors for the school year 25-26. We'll just see how far we get on this video today. So, you don't need to worry about this. That's a standard number, not important to you. And this level just basically tells you the difficulty, if you want to think of it that way. It's really just saying the depth of knowledge, and these levels go from 1 to 5. So a level 3 is harder to at a depth of knowledge than a level 2, so on and so forth. For questions 1 and 2, we're going to use these two images. Now, I hope that on your copy you can see these lines a little bit better than we can see them on mine. So I'm just going to draw my tick marks in a little bit better, just so they are more obvious for the video. Okay. And that one goes all the way down to -10, like that. Great. We have to use these two images, and numbers 1 and 2 have us comparing these two things for domain and range values. I will go ahead and tell you though, unfortunately, number 1 has a mistake in it that I didn't catch until after I ran the copies. I am so sorry. I didn't make the review. I just didn't proof it before I ran copies. Maybe. Also, I know that yours were a lot smaller than mine, and that is because I didn't want to burn down all the rainforests when I ran the copies. So yours are 2 pages per 1 page, but for the video, I wanted to make sure that you could see it all at a good size, so it is not super duper small. Okay. Anyway, number 1 asks us to compare the domains of the two functions. So let's look at our domains. The domain of f is all the numbers between x equals -1 and x equals +1, 2. So those are the domain values. That's from and including -1 to 2. The domain of g is all the numbers from x equals -2 to x equals 3. And I told you 1 has a typo in it, so we're going to talk about these numbers because this one's talking about the left side, maximum values of the domain of f. So if you look at the domain of f, its maximum value is 2, and none of these say that the maximum value of the domain of f is 2. So actually every one of these statements is false, unfortunately. So what we're going to have to do is we're going to have to rely on the other part to answer this. We'll just pretend it didn't say any wrong statements over here. And this one over here, they all say the maximum value of the domain of g. The maximum value of the domain of g is 3. So I would argue that this is the only correct thing to say. In order for this to be a true statement, it would have needed to have said that the maximum value in the domain of f is 2. That number would have needed to be a 2 for this to be the correct answer. But, I don't know. Barring any major mess-ups, hopefully that's not too difficult. Number 2 is asking us to compare the ranges of these two functions. So let me come back up to these images and let's write down our ranges. Purple and green. We'll do range of f. So that's the y values that f covers up. Looks to me like f's smallest y value is +1, while f's largest y value is +4. So that is going to literally range from 1 to 4. Didn't mean to have that kind of pun, but hey, I'll take it. And the range of g, remember we're always writing these things from small to big. So if I'm looking at g's y values, I see its lowest y value is right down here at -10, and I see its highest y value is right here on the x-axis, which is a y value of 0. The range of g goes from -10 to 0. Now we get to use these 4 numbers to come down and look for a true statement. Everything on the left here says the minimum value in the range of f. The minimum value in the range of f is 1. That makes C the correct answer. Let's just make sure that there's no other mistakes. Is the minimum value in the range of g -10? Yes, it is. So that is the correct answer for example C. There it is. Cool beans. Question 3. Now I told you that I'm going to be showing you how to utilize Desmos and or graphing calculator technology to crush all of these questions. So because we're trying to do these things with ease and get them right on that midterm, I will talk about how you could do this by hand, but I'm just going to do it on Desmos. So our job is to compare the relative maxima and minima of these two functions. That would require you to find the maximum values and minimum values of the two functions, and because they're both quadratics, the maximum and minimum values will always occur at the vertex. So you could find the vertex of this using x equals negative b over 2a. That would be the axis of symmetry. Then substitute that number back in to get your y value. The y value is actually the minimum or maximum value. Because this points up, it makes a smiley face. That graph would have a minimum. This graph, because it starts with a negative number, would be a frowny face, would have a maximum. But again, negative b over 2a, x equals negative b over 2a would get you the axis of symmetry. You'd then have to plug that in, make sure you'd use parentheses, that way you don't accidentally square a negative number, all that stuff to get its y value. I know this one has a minimum, I know this one has a maximum, so I could at least do E and F without doing any work. It says F has a maximum. No, it doesn't. The graph of F looks like this because it's a smiley face graph. And the graph for G looks like this because it's got a negative number in the front. So no, the graph of F does not have a maximum. So I know that this is garbage. G has a maximum, yes. F has a minimum, yes. I know that is a correct answer, but if we read the instructions, it says select all that apply. And to be real with you, I don't want to do more work, so I'm going to put these two functions into Desmos. So I'm going to pop on over to Desmos. You won't be able to see the functions anymore, but I can. We've got f of x, equals. X on the keyboard, I just used the symbol above the 6 to get the square, the little caret symbol. Or you could use this. Well, that'll always give you a square. But let's say I wanted any exponent. X squared. But if I wanted to say a third power, x raised to the 3. I didn't mean to type 2 x's, but you get the idea. Okay. So x squared, and then plus 2x plus 8. There's my f of x. You can't see it because I'm zoomed in. We just zoom out. It's here somewhere. There it is. Okay. And I'm going to press enter. G of x. By the way, I was zooming out using the scroll wheel on my mouse. The laptops are touchscreen, so you could just pinch and drag like you would on your phone. G of x equals negative x squared minus 2x plus 6. There's my two graphs. You can see your answer choices on the paper just like I can see the answer choices on my paper. And you know what? Ooh, I'm going to get really fancy. Check this out. Boink. And I want to see this on the left hand. Oh boy. Yeah, oh look, it's nice and small just like it is on yours. Do both of my extreme values, my minimums and maximums, lie to the left of the y-axis? They sure do. My y-axis is this right here. So yeah, they're both on the left. So A is a correct answer. Can both extrema lie on the right side? Well, that's not even possible if they're both on the left. The extreme value for F is greater than the one for G. Guess what, folks? Both of these graphs have the same vertex. That means that the minimum of one is the maximum of the other. So it is not possible for them to have different. Come on now. I am just trying to get this screen to maximize. I'm going to pause this. There, I figured it out. It is not possible for the extrema of one to be greater than the extrema for the other. So those are all also bad answers. The only two answers that are correct are A and F. Woohoo! Number 4. It says compare the graphs. Mr. M, what graphs? Well, first of all, this table is missing some lines. There we go. You have options here, okay? You could use Desmos, and I'm going to show you how in just a second. But I'll be real with you, I do think that this question is faster if you just sketch these two without actually going to Desmos, because it just says one of these is true, and once again it's talking about the minimums and maximums. So it's literally just looking at the y values. However, do they both have a minimum is the question. Well, you know what? Screw it. Let's just put it on Desmos. I'll just show you how to put it on Desmos. I mean, I could sketch this by hand, but what's the point? Let's just put it right to Desmos. You can put this table on Desmos. Isn't that cool? All right, so to Desmos we go. And maximize the screen. I will get rid of these two things and zoom out a little bit, as I don't really know how big. Okay, so right here, you're going to click the plus sign, and you're going to add a table. The x values are in your table. -4, enter. -3, enter. And look at that. It already knows I'm counting by ones. There. There's my whole table from -4 to +1. Now this one is f. And notice I didn't do of x. That'll confuse it, so don't do that. I've got 4, 1, 0, 1, 4, 9. And you can see you have a parabola here. If you would like its equation, then you click right here. You can see it's a parabola, so you change it from linear regression to quadratic regression. And you see this button right here. It exports it, boink, as a function. There it is. Okay? Okay. Now, let's add function g and type in its y values. -14, enter. -7, enter. -2, enter. 1, 2, 1. And if you would like to see its function, you would do the exact same thing, but right here you would change this from f to g, and then boink, do like that. Great. So there's our two functions. The red one is f, the green one is g, which you could see right here. See? F. Why didn't it make that purple? That's stupid. Well, that's really confusing actually. This one was f, and f is the red one. Oh boy. Isn't it? Yeah. It changed the order of these two. That's really weird. Huh. Okay, we got to be smart about that, all right? I guess just pay attention to the colors as it makes them. So here's my red one, here's my green one. You can see your questions. It says both parabolas have a minimum. This one has a minimum, this one has a maximum. So obviously A is false. It says the minimum of f, which is this point right here, is greater than the maximum of g. No, this is definitely lower than this point. So B is false. C, the minimum of f, which is 0, is less than the maximum of g, which is 2. Is 0 less than 2? It sure is. Then the answer is C. D says the minimum of f is greater. 0 is greater than 2? Obviously false. So the answer is just C. That is how you can use Desmos to do something like that. Or you could have just sketched it. What I noticed when I was looking at this is I see that around this number, the 1s match, the 4s match. That tells me that's my vertex. And since these numbers go up to the left and to the right, I know that f points up. And I knew that this value was at -2, 0. This was for f. I looked here and I looked for where the numbers repeat, and I see them repeating right here. That's the only time I see them repeating. You know, all quadratics. We didn't know it was a quadratic, and that's why you could have sketched it, but even then, I would hope that it's a quadratic, because what else would it be? This shows a maximum value, and it shows me as I go to the left and to the right, my numbers go down. It did like this. So here's g. And I could see that this one is at where the values got symmetric, so 0, 2. So even without sketching, you can see that that's a minimum value of 0, that's a maximum value of 2. C is the only thing that makes any sense. I think it's just faster to do it that way, but you would have had to have assumed it was a parabola, because it didn't say that it was a parabola. And number 5, talking about symmetry, even, odd, neither. Okay, in order to pull this off, we're going to have to get a quick review of what that means and what that looks like, okay? For even symmetry, All graphs that have even symmetry are symmetric around the y-axis. So instead of using a graph, let me use an image. And just to show you direction, I'll put a purple circle there. All even graphs use the y-axis as a line of reflection. If your graph has this property where the left and the right-hand side of the y-axis look exactly the same, only mirror images of each other, then you have an even function. And this kind of looks like a goofy face, just a happy coincidence, I guess. So does this graph look exactly the same on the left-hand side and the right-hand side of the y-axis, just mirror images? It sure doesn't. So it cannot be even. Let's check out what odd functions are. Let me do it over here. Odd functions will all have this kind of property going for them. So I'm going to draw my same house. Odd functions will do this. Notice that my house is pointing up with the purple circle on the right. All odd functions can be spun perfectly around 0, 0, half a circle, and get the exact same picture. Oh, look, an upwards facing house with the circle on the right side. That is how you know if something is odd. Now, is it always going to be this quadrant and this quadrant? No, but all odd functions will have what you call rotational symmetry around 0, 0. And if you can do a half circle turn around 0, 0 and get the exact same picture, then it's an odd function. This one is odd, but only because this point is on 0, 0. If this graph had been shifted anywhere, up, down, left, or right, then it would have had neither even nor odd symmetry. Now, one of the most important properties of odd functions is that they are going to have the property where if you change the sign of x, you change the sign of y. And you might be asking yourself, well, huh? Well, check this out. Let's grab a pretty point that's on here. And I know it's hard to see, but it looks as though I have a pretty point at 2, -5. And if you switch the sign of x, switch the sign of y, you get -2, +5, and you will notice that -2, +5 is also on the graph. So the algebraic rule for odd is if you multiply x by -1, you have to multiply y by -1. The algebraic property for even is if you multiply x by -1, you do nothing to y. So there it is. And I think I'm going to do one more, and we're going to call this a video for today. So first 6 questions. Let's see what number 6 is. Oh, even, odd, or neither. Great. Now this one's without a graph, but you have Desmos, don't you? So let's slide on over to Desmos. And I am going to do it algebraically as well, but hey, let's work smarter, not harder. So let's go to Desmos. Let me get rid of these. Scroll up, get rid of that. All right. And I'm just going to type this function. X raised to the 4th right arrow plus x. And if you use my house thing that I talked about a second ago, you can see that the left-hand side of the y-axis is not exactly the same as the right-hand side of the y-axis, so it can't be even. And if you turn this thing half a circle, there's no way you're going to get the exact same picture. So it can't be odd either. This graph is neither even nor odd. But what is the rule? Well, here's the even rule. Multiplying your x by -1 does absolutely nothing to the y values. Okay, but if you're going to apply this rule, what that means is substituting -x in for wherever your x is, after you clean it up, should get you the exact same thing back. So let's prove it's not even. Let's do f of -x. Personally, I think just using Desmos to recognize that it's not even is easiest, but hey, I'm going to give you all the options and hope that it's enough to get you a 100. Let's clean it up. Anytime you multiply 4 negative numbers, you're going to get a positive result. So positive x to the 4th, because that's negative x times negative x times negative x times negative x. This one, though, is just minus x. Do you see how this is not exactly the same as your original f of x? That's why it's not even. But that doesn't automatically make it odd. Here is the rule for odd. If you replace your x with negative x, which we've already done, which is really nice, we already know what that result is going to be. That's this result right here. It gets you this result. If this happens, then it's odd. All right, well, let's see. We already know that what f of negative x is. Here's f of negative x. We just found that. It got me x to the 4th minus x. Let's find negative f of x. That means multiply f of x by negative 1. But if you're going to do that, you have to do it to the whole side. So multiply the left by negative 1, multiply the right by negative 1, clean it up and see what you get. It's going to give you negative x to the 4th minus x. And as you can see, that f of negative x does not equal negative f of x. So it's also not odd. See how much work I had to do to show that it was neither even nor odd? So much easier just to know what the images look like and use Desmos. I think that's a great place to stop for today, and hopefully, since we are 22 minutes deep, this video recorded with good audio, because the first time I did it, there was no audio. Deuces, people.